Hi folks, welcome back to Honors Math. We've got this nice trig identity to work on today. We're going to look at a couple of different concepts during this video. The first thing we're going to notice is that the left-hand side has two trinomials, and we're going to work with that left side. I'll drop my wall here. But before we do that, we're going to notice that the tangent theta plus secant theta is the same as sine theta over cosine theta plus 1 over cosine theta. And of course, that's the same as sine theta plus 1 all over cosine theta. So we're going to use a technique that I talked about the other day, and that was when we have a fraction like this one, that we're going to take the more complicated part of that fraction, that numerator, is a little more complicated than cosine theta, and we're going to use it on the left side of our equation. So instead of working on the right side to try to create that monster fraction on the left, we're simply going to take tangent theta plus secant theta minus 1. We're going to take this tangent theta minus secant theta plus 1, and we're going to multiply the top and the bottom by this item right over here. All right, so all we're doing on the right side is we're getting a clue as to what we should be doing on the left side. So sine theta plus 1, sine theta plus 1. Staying with our rule of identities, which is you are not allowed to multiply through the equal sign here, and so we're just going to multiply top and bottom. So a couple things are happening. First of all, we know that our numerator is actually Our numerator is actually complete. This sine theta plus 1 is we're going to want to keep that there the entire time. The denominator, we're going to try to generate a cosine of theta eventually in our denominator. So let's see if we can do that. The first thing I would like to ask permission for is I'd like to ask permission to just leave the numerator alone and not have to rewrite it every time. So if it's all right with you folks, I'm going to just go ahead and put I'm going to put a little flower here. That flower means I just rewrote this numerator. Yeah, pretty fancy trick there. Sorry about that, but I'm too lazy to write this over and over again. In the denominator, I'm actually going to multiply. So first I'm going to multiply the tangent times the sine, which would give me sine squared theta over cosine theta. Then I'm going to multiply the next one, so I'm distributing my sine. Multiply the sine times the negative or the subtraction of secant. That should give you minus sine theta over cosine theta. That's a tangent, but I'm going to hold off on that for a minute. And then this one, the last one, is plus sine theta. So I just multiplied the sine through to all three terms. Now I'll multiply the 1 through. I get a plus tangent theta. I get a minus secant theta, and I get a plus 1. Well, I guess I probably should have written that as a tangent since those two items drop out. So I'm going to do two things at once here in the bottom. First of all, I'm going to rewrite my numerator. How do you like that? And then I'm going to write in the denominator that this first fraction right here, I'm going to rewrite as 1 minus cosine squared theta using my Pythagorean identity, because I know I want to be in cosine if possible, and then plus sine theta minus secant theta plus 1. Okay, so far, maybe so good. Let's find out. Rewrite that numerator one more time. This fraction in front becomes secant theta, as I separate it, minus cosine theta. Let me move everything up a bit. Plus sine theta minus secant theta plus 1. And now my secants drop out. And I'm going to rewrite this just briefly here, but I'm going to rewrite my numerator one more time. My numerator is becoming uglier and uglier as I go along here. I'm going to bring my sine out front, sine theta, and I'm going to write plus 1 minus cosine theta, if that's all right. That's just looking ahead. All right. So remember that my numerator way back up over here already has the sine theta plus 1 in it. And we want to cancel this other part. So we're going to need a fancy math trick here. And here's how we're going to do it. I am going to factor a cosine out of those three terms. Now I know you're thinking you can't factor a cosine out of a sine, but watch, I'll do it. So in my numerator, it's time to rewrite now. I'm going to have sine theta plus 1 multiplied by tangent theta plus secant theta minus 1. My denominator, now I'm factoring out the cosine because I needed a cosine. And if I do that, let's look at what's left over. If I factor a cosine out of a sine, I get tangent theta. If I factor a cosine out of the number 1, I get a secant theta. And if I factor a cosine out of itself, I get minus 1. I know, you think I'm brilliant, don't you? No, I'm just doing a little fancy math trick there. But then, when those two items cancel, we're left with sine theta plus 1 over cosine theta, which finishes our identity. Well, I hope you would agree that this last step right here was very, very, very important in working this out. The second problem has a totally different mindset. On the right-hand side, I have a really nice fraction. This one's very pretty, so I'll just put my happy face right away. But on the left side, I think it's just a matter of combining terms. So for the first fraction, I'm going to write 2 sine x over cosine x all over 1 minus sine squared x over cosine squared x plus, and again, I'm going to do a little fancy math trick on the second fraction, and let me show you why. I'm trying to bring these two fractions together, and I see I've got a 2 right here. And that 2 probably isn't going to do me very well. So what I'm going to try is I'm going to try a fancy little math trick. I'm going to write 2 cosine squared x minus, and instead of the number 1, I'm going to write out the Pythagorean identity for sine and cosine. So I'm going to write cosine squared x plus sine squared x. And you can see how this is going to simplify, well, in some ways simplify, that right-hand fraction. And if you're really bright, you might even notice how it's going to end up looking very much like the fraction on the other side of the equal sign. All right, one more thing on the left-hand side. I'm going to multiply top and bottom by cosine squared x in top and bottom, and go ahead and distribute that through. So in the numerator, I end up with the following: 2 sine x cosine x. In my denominator, I end up with cosine squared x minus sine squared x. And this other fraction ends up subtracting the cosine, so I end up with just cosine squared x minus sine squared x. All right, so what was the trick? The trick was turning the number 1 into a sine squared x plus cosine squared x. Let's see if that works for us one more time. I'm going to rewrite this as cosine squared x minus sine squared x in my denominator. I've got a 2 sine x cosine x plus, let's try it. Let's go to the well one more time. Cosine squared x plus sine squared x. A little rearranging in this numerator might be wise. That's going to give me cosine squared x plus 2 sine x cosine x plus sine squared x all over, hey, let's go ahead and factor this denominator, shall we? That would be a nice idea. Cosine x minus sine x, cosine x plus sine x. And look at that numerator. Isn't that beautiful? That also factors to cosine x plus sine x times itself, or squared. And let's leave that cosine x minus sine x multiplied by cosine x plus sine x in my denominator. Look at how nice that looks. It's going to cancel out for us, and we're going to end up with a cosine x plus sine x in the top, and our denominator cosine x minus sine x. Oh my goodness. Could you ever think that this set of fractions when it was going to get us there? Well, remember what our keys were. Right over here and right over here, we use the same concept, turning the number 1 into cosine squared x plus sine squared x. All right, I hope that helped out a little bit. Obviously, we've got very challenging identities in this section.